So what's up guys, welcome to this video on rationalizing denominators. So what is rationalizing the denominator? So if you used to put this expression 1 over root 2 into your calculator, it would give you a different value, okay? It would give you something else. It would give you root 2 over 2. Now why does it do that? It does that because we want to make it a rational number, okay? When we have something like this, where we have the denominator as a square root, it's not in its best form, okay? It can be a bit difficult to work out its the actual value, okay? So what a calculator does is it writes it as a rational number. But how do we get from 1 over root 2 to root 2 over 2? Well, that is where rationalizing the denominator comes into play. So in this type of question, what we would do is we would times it by root 2 over root 2. Now, why do we do that? Well, we know that if we times by root 2 over root 2, we're timesing it by 1 because root 2 over root 2 is essentially just 1. So we're timesing it by 1. So we're not timesing it by any other value, which means that we're not actually changing anything about the number itself. But why do we times it by root 2 over 2? Because by doing that, we can get rid of the square root on the denominator. So if we were to work this out, 1 times root 2 is root 2. And from our previous lesson, we know that root 2 times root 2 is just simply 2. Okay? And now we have simplified down, we have rationalized the denominator. So we know that 1 over root 2 is equal to root 2 over 2. And feel free to use your calculator. If you put 1 over root 2 into your calculator, it will just give you root 2 over 2. The calculator will always give it to you in the rational form. So with this question, we now have 1 over 3 plus root 2. And we want to do the same thing. We want to rationalize the denominator. Well, how do we do that when we have this type of question? Well, it's what we need to think of is how can we get rid of that root 2? Well, there are loads of ways you can get rid of it, but the easiest way is to think of it like a difference of two squares, okay? Remember when we had something like x squared minus 1, for example? We know that equals x plus 1, x minus 1, okay? And what that effectively does is why I say you want to think of it like that, because we can apply the same trick, the same method to these type of questions. So if I do that now with this, what we want to times it by is we want to times it by 1 over 3 plus root 2, and we want to times it by 3 minus root 2 divided by 3 minus root 2, okay? So we think of it like a difference of two squares, because that will, in turn, get rid of our brackets of our square roots. So if we work this out, okay, we would get a 1 times a 3 minus root 2 is simply just a 3 minus root 2. And then if we work this out, I'll do it in full. So we do 3 times 3, which is 9. Then we do the 3 times a minus root 2, which is a minus 3 root 2. Then we do a root 2 times a 3, which is a positive 3 root 2. And then we get a root 2 times a root 2, a negative root 2. So that'll give us a negative 2. Okay? I'll just scroll up a bit. And then if we were to simplify this down a bit, then we would get a 3 minus root 2. And then that would be a 9 minus 2 is 7. And then the minus 3 root 2 cancels out with the 3 root 2 here. They cancel out. So we're just left with this expression, which is 3 minus root 2 all divided by 7, okay? The reason why we change the signs is because, again, we get rid of the root in the middle. So that's why you can think of it like a difference of two squares. So when you have a question like that, just change the sign in the middle. Okay, so let's do 1 over root 5. If we were to rationalize the denominator, Therefore, we would get 1 over root 5 times by root 5 over root 5, which would give us a root 5 over 5. So about this question, we have the root 3 over root 15. So there are loads of ways you can work this out. I'm going to show you two ways. So the first way is, what we can do is we can actually simplify this down. So we have a root 3, and that square root of 15 can actually simplify down to root 3 times root 5. And then if you simplify that down even more, the square root of 3's cancel out. So you're left with 1 over root 5. And now we can just rationalize the 1 over root 5. And if you saw from our previous question, you'll know that 1 over root 5, that would just rationalize into root 5 over 5. There's also another way we can do this question as well. This way also is the quicker way, but if you maybe you don't see that, therefore just do it like normal. So if we rationalize the denominator of the square root of 3 times the square root of 15, then we would times it by root 15 over root 15. If you're to do that, you would get the square root of 3 times the square root of 15. That would just give us a square root of 45, and that is divided by the square root of 15 times the square root of 15, which would just give us 15. Okay, so now we need to simplify down the square root of 45. So very similar to what we did in our previous lesson. To simplify down the surd, just got to think of the highest square number factor. In this case, that would be 9, because 9 times 5 gives us 45. So therefore, we would get square root of 9, the square root of 5 divided by 15, and that's the square root of 9 is 3. So we get 3 root 5 over 15, and then the 3 and the 15 that can cancel down, so that'll be 1, and then that will be 5, which therefore gives us also the square root of 5 over 5. So for this question, we have a root 17 minus root 11, and that is divided by root 17 plus root 11. So for this question, again, what that means is we will be multiplying by the square root of 17 minus the square root of 11, and that is divided by the same thing. Okay, so now how do we go about solving this type of question? It is exactly the same way. So if I just put everything together, we get the square root of 17 minus the square root of 11. That is being times by itself, the square root of 17 minus the square root of 11, and that is being times by the square root of 17 plus the square root of 11 times by the square root of 17 minus the square root of 11. So again, to solve this type of question, we would do the root 17 times by a root 17. If you work that out, you will just get 17 because you're timesing it by itself. For this bit in the middle, you get a square root of 17 times by the minus square root of 11. So if you work that out, it'll be minus the square root of 17 times 11. A quick trick with that, just do 1 plus 7, that gives you 8. So we know the number in the middle is just 8, so it's 187. And then we have another a negative square root of 11 times the square root of 17. So we get another minus square root of 187, and then we get a minus root 11 times a minus root 11, which will give us a minus under minus is a positive, so a positive 11. Okay, and then the bottom half, we know that it's a difference of two squares, so we don't need to worry about the things in the middle. We can just do the square root of 17 times the square root of 17, which is 17. And then we can just do the square root of 11 times by the negative square root of 11, which is just minus 11. Okay, so now we're at this stage. If I just scroll up a bit, now we are at this stage. If we start to simplify down, we have 17 plus 11, which is 28. We have a minus 1 lots of root 187 minus another lot of root 187. So that's minus 2 lots of root 187. And we have 17 minus 11, which is just 6. But we are not done just yet, because all of those numbers we can divide through by 2. So if I quickly just do that here for you, we can rewrite this as 2 and then 14 minus the square root of 187. Okay, and that's over 6. And then this can cancel down. This will be 1. This will be 3. So therefore, our answer is 14. Oh, and we'll do that 4 again. 14 minus the square root of 187. And that is divided by 3. Okay, so for this question, we have 2 over 5 minus root 3 times 2 plus root 3. To do this question, first thing first, we need to expand the brackets on the denominator first, and then we just apply the normal formula we've been doing this whole time. So if we do that for this question, what we get is we get 2. So then we get 5 times 2, which is 10. 5 plus root 3 is a 5 root 3. We get a minus root 3 times 2, which is a minus 2 root 3. And then we get a minus root 3 times a root 3, which is just a minus 3. Okay? And therefore, this is 2. And then we get a 10 minus 3, which is 7. And then we get a 5 root 3 minus a 2 root 3, which is positive 3 root 3. Okay? And now we're at this stage. Now we can apply the tactics we've been using in previous questions to work this out. So if I just scroll up again. Okay, so now we have 2 over 7 plus 3 root 3. And we just do the same things we've been doing in previous questions. So we can multiply by 7 minus 3 root 3. So if we do that, therefore we will get a 2 times 7 is a 14 minus a 6 root 3. That is divided by, we get 7 times 7, which is 49. And then we don't need to worry about the middle bit, because we'd get a 21 root 3 minus a 21 root 3. They just cancel out. So don't need to worry about the middle bit. We can just go straight to the 3 root 3 times by the 3 root 3. And if you were to do that, you would get a 3 times a 3, so that'll give us a minus 9 times a 3. Okay, because we get the normal 3 times the minus 3, which is a minus 9, and then we have the root 3 also times root 3, which is a normal 3. If we simplify this down, we get a 14 minus 6 root 3. And then that is 49 minus 9 times 3, which that's 49 minus 27, which is 22. Okay, so now we have 14 minus 6 root 3 over 22. We can simplify this down. All numbers go into 2. So if I do that here, we get a 2, a 7 minus a 3 root 3 divided by 22. Simplify this down. Then we get a 1 here, we get 11 here. Therefore, we are left with 7 minus 3 root 3, and that is over 11. Okay. So for our last question here, we have an exam style question. We have 3 minus 2 root 5 over root 5 minus 1. And we want to give an answer in this form here. We want to give an answer in the form of p plus q root 5, where p and q, they are both rational numbers. Okay. So how do we go about doing a question like this? We just treat it the exact same we've been doing for all the other questions. Okay, no different. It may look a bit different, but we treat it the same. So what we would do is we would times by root 5 plus 1 over root 5 plus 1. So if I do that here, we get 3 plus minus 2 root 5, and that is times by root 5 plus 1. and then that is divided by root 5 minus 1, and that is times by root 5 plus 1. Okay, so if we work this out, therefore, what would we get? So let's do it down here. We would get a 3 times a root 5, which is 3 root 5. We would get a 3 times a 1, which is just a 3. We get a minus 2 root 5 times root 5. So what is that? So we get a root 5 times a root 5, which is just 5. A minus 2 times a 5, that is a minus 10. Okay. And therefore, we also have a minus 2 root 5 times a 1. So that would be a minus 2 root 5. Okay. And then on the bottom, we would get a root 5 times a root 5, which is a 5. And then a minus 1 times a 1, which is a minus 1. Remember, we don't need to do the bits in between because they will cancel each other out. So if we simplify this down, we get a 3 root 5 minus a 2 root 5. That would give us just a root 5, okay? And then we have a 3 minus a 10. That will give us a 7, a minus 7. And then that is divided by 5 minus 1, which is simply just 4. So now we have root 5 minus 7 over 4, and only in the top we have to write in the form of p plus q root 5. Well, this may not look like it, but remember that p and q need to be rational numbers, okay? So they need to be rational numbers, then effectively this is the same as writing a quarter root 5 minus 7 over 4, where in this case p would be minus 7 over 4. That's still a rational number. And q would be just simply 1 over 4. So you can just leave your answer as 1 over 4 root 5 minus 7 over 4. That is perfectly fine. But that will be it for this lesson. I hope you enjoyed it. And in our next lesson, we'll be going over chapter 2. Okay? So, I hope you enjoyed this, and I will see you soon.